In this video, we're going to talk about something called index numbers. Let me write a few examples down and then we'll go into more detail. So some examples. Of index numbers. For you, the consumer, this one is important. The CPI. This is the Consumer Price Index. There's the PPI. That's the Producer Price Index. There's the CCI, Consumer Confidence Index. And each of these has its own specialization. It's going to, the Consumer Price Index, for example, is going to keep track of, well, what consumers normally pay. And there's about 60,000 or so items that they take the average of, and it's an extraordinarily complex formula, but that number is produced monthly, and we can take an average, a yearly average to work with. Now, whenever we use, an equation like this is going to be set up. If we're talking about years, let's say years X and Y. Generally, this is the equation that we're going to have. We'll have whatever index number was that year divided by some sort of an amount for that year is going to equal some other index for Y over Y. And that price may be, I'm going to put dollar signs here, because that'll be the dollar signs you pay in each of those individual years. So, or another way we could do this, we could do the reference of X over X equals the reference of Y over Y. So let me do an example to illustrate this process. Suppose you purchased $60 worth of gas in 2020. How much would that same amount of gas have cost back in 1985? So I have a table that I want to reference here. And let me make it a little bit bigger. So what we can do here is we can set up an equation, or a proportion is a better way to put it. And I could take a look at the $20 worth of gas. Let's say here, I'll put it on the bottom. And that was in 2020. So a reference number that we can use for 2020 is this price, probably per gallon if I had to guess. So we're going to have $2.26. On the other hand, so that was for the year 2020. And then for the year 1985, let me fill out the corresponding details. The reference number here, this 226, is $1.20. And we don't know what the price was back then. Now, to remind you on how to solve these equations, we do what's called cross multiplication. So I'm going to drop all the dollar signs and let me go and just work with the numbers. I'll put in whatever units I need to at the end. So let me do the cross multiplying schematic again. So I'll get 2.26 times P equals 20 times 1.20. And that's going to be 24 on that side and 2.26P on the left. And now I'm going to divide both sides by 2.26. 24 divided by 2.26 gives me, I'll round my answer to two places. It looks like $10.62. Now, I could have actually set up a slightly different equation. The reference numbers I used were the prices per gallon. I could use different reference numbers. I could use these index values, for example. For 1985, I have 100, and for 2020, I have 183.3. So we could do the indexes instead. I could set up 100 divided by, in 1985, we don't know what the price was. But then in 2020, we have the index value 188.3, and we know that we paid $20 back then. And once again, I'll drop the dollar sign and I'll add what I need to at the end. So I'll cross multiply. I know I'll get 100 times 20 is 2,000. And on the other side, I get 188.3p. So now to get the price, I'll divide by the 188.3. This time, I get about $10.62. So they're slightly different from each other, but they both give pretty much the same kind of an answer. To calculate an index number, here's the formula. Index number equals, and we're going to take some value that we have and divide it by some reference and multiply it by 100. Not 100%, just 100. Let me make my multiplication look a little better. Here we have the cost of gasoline today is $2.70 per gallon. Use the 1985 price as the reference value. So when they talk about the price index, they're talking about this formula. So the value today is $2.70. Now, the value of a gallon for 1985, let me come back and look at that table again. From 1985, that same gallon of gas was $1.20. So that'll be my reference. That's what they said to use. Use 1985 price as a reference. So I'll put $1.20 here, and then you've got to multiply by 100. Notice that the dollar signs will disappear here. And I think you'll find this equals 225. That number, the 225, means that gas in 2020 was 225% more than what it was in 1985. So 2.25 times is expensive. All right, here's an example. This is table 3D.1 right here. Let me work part A first. Suppose it cost $16 to fill a gas tank in 1985. How much would it cost to do the same in 2015? You can do this in two ways. Here, you set up a proportion. Since I'm trying to find out or solve for an unknown quantity, I'll set up a proportion, an equation that can be solved. So for example, in 1985, the gas tank was $16. So what we can use for our index here, if we want, is $1.20. So we could do $1.20 divided by $16. And then we can go to 2015. Here we have $2.52 is how much it is per gallon. And we'd like to know how much that cost. So this was 2015. This was 1985. Once again, I'm going to drop all the dollar signs, and I'm just going to write the equation without all that. And to solve for P, you cross multiply. The other side, I need to do 2.52 times 16. I get 40.32, divide by 1.20, divide by 1.20, and we'll get our P. So it looks like we get $33.60 is how much that would cost. Now, as I mentioned, there's a second way of doing this, alternative. Instead of using the prices, I could have used my index numbers here, and what was the other number, 2015, here. And then what I could have done is set up my 100.0, there's my index number, divided by the $16 that I spent, that's in 1985. And that equals, then in 2015, I put my index number on the top, that's the 210.0, and the price down here I would like to know. Cross multiplying, let me go down here, I'll get 100p equals 210 times 16. $33.60, and then divide by 100, and you'll see you get the exact same answer, although that's not guaranteed to happen every time. And then just don't forget to put your dollar signs at the end of all of it. There was a part B. Let's see what that asked me to do. Here it cost $20 to fill a tank in 2005. How much did it cost in 1965? So $20 in 2005. So we spent $20. Actually, I usually put those on the bottom. Let's put those on the bottom then. $20. And when did I buy this? In 2005. So you can choose the dollar price or the index value. Let me look. I'm going to use the index value for 2005. So I'm going to use 192.5. And then 1965. We don't know how much it would have cost, so I'm going to put P for how much the price was. And then let me go to the table. The price index for 1965 was this, 25.8. And let me cross multiply. That number there is a 1. So I'll put my work over here. I'm going to get 192.5 P equals 20 times 25.8. On the right side, I get 516. On the left, I still have the 192.5 P. I'll divide by the 192.5. 192.5 P equals And I'll round to 2 decimal places because it is dollars and cents. I get $2.68. You may want to retry doing this problem, instead using the price per gallons in place of the index numbers, and you should get similar answer. This example specifically wants us to use the 2005 price as a reference value. Let me see if I still have that thing. So this one here is comparing today's with the 2005 price. So we have gasoline price today is $2.70, and then it says use the 2005 price as a reference value. So what do they want us to do here? Find the price index. So that's the key. Remember, an index has a different value, a different formula. The index number, let's call it this. This is some value divided by a reference times 100. What's the value that we're going to use? Well, they say to use the reference of the 2005 price. So this is our reference right here. So I'm going to put 231 up under there. Now, the value that you use should be the same type of data. So if I used price in the denominator, I also need to use price in the numerator. Of course, the value we want to put in is the cost now, which is $2.70. Notice that the dollars cancel out. You can ignore the dollar signs, of course, they do cancel out as I mentioned, but I'll do 2.7 divided by 2.31, enter, and then I'm going to multiply that by 100. And I get 116.88. This is supposed to be, well, no, it's an index number. They never do index numbers to that many decimal places, so we should really do 116.9. Now we move on to one of the most important indices, and that's the Consumer Price Index. Here you can see that it's based on the prices of more than 60,000 goods, services, and housing costs. It's computed and reported monthly. Here you can see the components of the CPI. The biggest cost for humans is also the biggest sections of this particular pie graph. You can see healthcare, food, beverages, transportation, housing, all those things do take up the most amount of our monies. Here's an example that's going to use the Consumer Price Index in our calculations. Suppose you need an income of $40,000 to maintain a particular standard of living in 2014. How much would you need in 2020 to maintain that exact same standard? And of course, the assumption is that things have grown according to the Consumer Price Index. So what we want to do here is we want to take a look at the CPI. So the index number for 2014, this is the notation your book uses. That'll be the CPI for 2014. And we were spending $40,000 back then. And then you want the CPI number for 2020. And we don't know how much we would have that day, so I'll just put a big X there. Now let me put in our numbers. All right, I've moved around a few things so we could see the numbers. This table that I just put up here comes from your textbook. And these numbers are readily available anyways. If you go on, say, Google and you just say CPI for 1981, you'll get 90.9. It's not always obvious. You may have to do a little digging, but these numbers are readily available. These are CPI numbers that are for the average of each year. Anyway, so here's how the equation is going to work. I'm going to put my CPI in 2014. So let me find it in this table. That's this guy right here. So I'm going to put the 236.7 in that spot, and I'm going to drop the $sign for a little while. And now let me find it for 2020. That's this down here. 258.8, and we don't know what the value is. So let's cross multiply. So on the right, I got 10,352,000. And on the left, I still have 236.7x. So I'm going to divide by the 236.7. Divide by 236.7. And it looks like $43,734.69. I'm just going to round to 43,735. I'm sure that's a pretty good and accurate approximation of what we would pay in 2020. The next topic is inflation. So if we want the inflation, so we're looking at the inflation rate from one year to another year. So say we're going starting from X year and going to Y a year. So the formula looks like this. We take the CPI of the remaining year, the end, the last one. We subtract from it the beginning CPI and divide also by the beginning CPI. And you multiply by 100%. You'll notice this is nothing different than relative error formula. That's all it is. Let me give you an example to illustrate. So to get this inflation rate, we're going to use the formula I just wrote. We're going to get the CPI for 2020. We're going to subtract the CPI for 2019. And we'll divide by the CPI from 2019. And we'll multiply that by 100%. Let me get my numbers. I can get them from the table up here. From 2020, we had 258.8. And then from 2019, it looks like 255.7. Divide by 255.7. And then multiply by 100%. Then divide by 255.7 and then multiply by 100. I'm just going to round to one decimal place here. That's about 1.2%. I had it down here, 1.2%. There's a second part. How does it compare into the late 80s? So let's do from 1989 to 1990. So the inflation rate for those years, we'll have the CPI for 1990 minus the CPI for 1989 divided by the CPI for 1989 times 100%. Let me get those numbers. The CPI from 1990 is 130.7, and the one before it was 124. So we have 130.7 minus 124, enter, divided by 124, enter, times 100%. Here we see about 5.4%. So prices were going up faster in the late 80s than they were going up in the late 90s. Another example. What was the inflation rate from 2021 to 2022? You recall this was at the height of the pandemic. So let's see if we can get, first of all, I need to get some information. The book only goes up to 2020. How do we get this? Well, I said they're published. So they're not hard to find, but they're not always extremely easy to find because the numbers they've been using a different way to represent the CPI than what used to be. So picking up the old representation is what I need to do. So what I'm going to do is go into Google, and I'm going to see what I can do if I type CPI for 2022. Of course, when you type that, it tells you what the average was for the year. That's the hope. And so as you can see here, I have 8%. That doesn't tell me much. I don't want that. Let's see if this down here tells me the CPI for 2022. Here we go. Oh, I lucked out here. I've got 292. So let me go ahead and grab that page here. So I guess I don't need those anymore. Instead, we're just going to do the inflation rate. That'll be CPI 2022 minus CPI 2021 divided by CPI 2021 times 100%. So let me put in my numbers. I got the 292.7 for 2022, and I have minus 271.0 divided by 271.0 times 100%. I end up with about 8.0%. And we happen to know, since we've lived through it, that that was a very high rate of inflation for the general overall economy to go up in price 8%. We saw how it happened. Here they give us the average salary of Major League Baseball players in 1987, and they also give them to you in 2020. So they want to compare the two averages in 2020 dollars. So what I'd like to know is, so what it looks like, since we're talking about 2020 dollars, the equation that we should have relating everything here is CPI 1987 divided by, let's say, the dollars in 1987. And then we'll have the CPI in 2020 divided by the dollars in 2020. So I guess I want to solve for this thing down here because they talked about the 2020 dollars. So let me fill everything else out. So this guy right here, we're going to call X. Now, let me put my CPI price here. We've done this several times. That's 258.8. And in the denominator, we're calling it X for now. And then the CPI for 1987, let me go to the table and see if I can find, for 1987, it's 113.6. And back then, we know that they were making $412,000. I'll put in the dollar signs at the end if I need. Cross multiply, so 113.6x equals 412,000 times 258.8. $106,625,600. Let me just check that 600 at the end. Make sure my number is right. 106,625,600. Good. And then my final step will be to divide both sides by 113.6. So I'll just take this number and divide it by 113.6. And I get 938,606. Let's suppose if the average salary would have kept up with inflation, so suppose they always were to do this. So then what should, let me put one thing here, if 2020's average salary was $4,430,000, what should have been the average salary back in 1985. So now the reference is going to be the 2000 salary. So now what we have is the CPI 1987, still goes there. At this time, I don't know what they were being paid or what they should have been paid. I don't know that number. Here I'll put my CPI 2020 and I'll divide it by the 4,430,000. Let me plug in my numbers. We now know that CPI 1987 was 113.6. And we know that the CPI for 2020 is 258.8. Let me cross multiply. $113.6 times 4,430,000 equals, so 503,248, 503,248,000. I'll divide by the 258.8. All I need to do is divide that by 258.8, and I get roughly 1,944,544. So if they were to have kept up with inflation, then they should have been paying those players back in 1987 an average of $1.9 million a year. Here we're looking at computer prices. A typical smartphone that cost $500 in 2020 had computing power roughly equivalent to that of a supercomputer that sold for $30 million in 1985. If computer prices had risen with inflation, how much would the supercomputer cost in 2020? What did this tell us about the cost of computing power? Let me explain one thing here. This here is absolutely unimportant to the problem. The only thing I need is this. So we can set up our formula again. I can do my CPI for 1985. And if you want, you can keep everything in terms of 30, so I can just do 30 down here. And when I report my answer, it'll be in millions. And then we have the CPI for 2020 over, and I don't know what the price is for then. Let me get my CPI prices. I don't know if we had 1985 before. No, let's come back here. We already know what it is in 2020. We've done that a bunch of times. 1985 looks like 107.6. So I have 107.6 divided by 30 million. And the CPI in 2020 is 258.8. X. Let's cross multiply. So 107.6x equals 30 times 258.8. 30 times 258.8 equals 7764. Let me divide by the 107.6. This is about 72.16. So remember, we're in millions. So we could just simply say about $72.16 million. What was the average annual inflation rate for 2020 to 2023? So what we could do for this, remember the inflation, and you could do it for more than 1 year. It's just we'll have to divide by the number of years when we're done. We'll do CPI 2023 minus CPI 2020 divided by CPI 2020 times 100%. Let me get those numbers down. 2023, I don't know if we had that in the table or not. Let's take a look. I don't know if it only went up to 2022. So let's see if I can find the 2023. Well, I already know the other numbers. While I'm here, I might as well put them in. And let's go hunting for the CPI for 2023. Now, when I did a search for this number, look what I searched on. I did CPI-U. I'm not exactly sure what that -U is, but I typed average for 2023. They'll give you some percentages and things like that, how much it increased from the previous year. But I'm only interested in this number, which is 304.7. So I'll put my 304.7 there, and I'll let my calculator handle the rest. So I have 304.7 minus 258.8 equals, divided by 258.8, and now I'm going to multiply by 100%. So we have about 17.7%. Here it is, 17.7%. That's for all of 3 years. If we want it only for 1 year, then we could say the inflation rate per year, that's going to be your 17.7% divided by 3, which gives us, let's divide by 3, about 5.9% per year. And in America, that's an unusually high interest rate. We were used to interest rates. We were used to inflation rates about 2 to 3% for many, many years. And just recently, they started going up a lot.